Back, everyone. For anyone watching this, I think this is lesson 50. It could be off now. Farther away we get from lesson 0, it all throws stuff off. But go ahead, take a moment, try to answer this do now based on the work we've done, and then we will talk about next steps. Go ahead. I'm going to answer. Just to reiterate, this is to bring up a good point of something we've covered. Negative 2 to the third. What does that mean? Well, it means negative 2 times negative 2 times negative 2. Because we have a base of negative 2 and 3 copies of it. How about negative 1 times x to the third? Well, that's negative 1 times x times x times x. How about the next one? Well, to be honest, it's not equal to this. Because this would equal negative x to the third. That's an annoying thing about exponents. There's actually really, well, what's really in front of this variable? Well, it's really a 1. And when we read it out loud, it's really negative 1 times x to the third. So that's negative 1 times x to the third. And negative 1 times x to the third, we already know what that is. So this is what's tricky. This is the same thing as this, which happens to be the same problem as here. Negative 2 to the third. It's even weirder. Well, the negative sign, even though it's part of the 2, it's really not part of the base because it's negative 1 times 2 to the third, which is negative 1 times 2 times 2 times 2. Just like this one up here. Just like, these two. The base is 2 with a negative outside. And it's tricky, and I know, but I did want to bring it up. If we wanted to have 3 copies of negative 2, this is the way we would write it. Negative 2 times negative 2 times negative 2 looks like that. This is 2 to the third power and make your answer negative. All right, this is chapter 6, lesson 5. We've left out an important thing, which mathematicians get specific about constantly, is the idea of simplifying with exponents, right? Or just simplifying in general. They always want it as simple as possible. So, what does it mean to simplify? It means like a trillion things, right? Okay, we're going to add one more piece to it. Mathematicians do not want to see any negative exponents or 0 exponents in a fully simplified expression. So, all bases with negative exponents must be in their positive form, and bases with a 0 exponents simplify out to the number 1. Okay, so when we're told to simplify, we can't have negative exponents. We have to do it in its positive form, and we can't have anything to the 0 power. It has to be in its 1. So for A, start off easy. T to the negative 4th, not simplified. Well, that's the same as 1 over t to the positive 4. And I know it doesn't feel more simplified, but it is because we can do some math with it. Okay, next one. We have 3 times r to the negative 5th. What's the exponent for r? Negative 5. What's the exponent for 3? Well, actually, it's interesting. It's 1. So it's 3 times r to the negative 5th. And since 3 is to the first power, we're good. We can leave it as 3. R to the negative 5th, not cool. That's 1 over r to the 5th. And we've talked about this back in like our second lesson. This times this is 3 over r to the 5th. Some things to notice, the negative exponent, like here. There it is, that's positive form. But 3 was cool, it's fine. All right, our third one, we're going to try to simplify. X to the first, is that okay? Definitely. Times y to the third. Does that need to get simplified? No. R to the negative fifth. Z to the negative fifth. Well, that actually is not okay, so we're going to write it as positive form. 1 over z to the fifth. That's like 90% correct. We want to push it a little further to say that x to the first times y to the third. Well, if I make these all over 1 and multiply straight across, we get x, y to the third over z to the fifth. What's interesting is notice that what got moved to the denominator? Well, the z's did, right? The x and y to the third stayed in the numerator, but it was the z's that moved to the denominator because of that negative exponent. Okay, and we're going to see that a lot, so I'm going to keep going with this one. All right, we're going to simplify. We have h to the 0 over 3. What is h to the 0 equal to? Or anything in the 0 power other than 0? It's 1. 3 is good. Boom, 1/3. That is simplified. Oof, we're about to get tricky. We have e, which is x to the negative third equals y to the fifth. Well, x to the negative third is equal to 1 over x to the third. Y to the fifth is fine. Okay, that would normally be the answer, but mathematicians are stupid. They don't like fractions inside of fractions, so we have to resolve this. And we can do it using division, so it's 1 over x to the third divided by y to the fifth, which equals 1 over x to the third times 1 over y to the fifth, right? Keep, change, flip. So if we simplify it, we get, 1 times 1 is 1, x to the third, y to the fifth. So this is the real simplified answer. Do I need all this work? No. More important is, that will help us with shortcuts, is take a look at where y to the fifth started. What do you notice? Where is y to the fifth located the entire time in all these processes? Stays in the denominator, right? Because it is in the denominator and it doesn't have a negative exponent. But take a look at this. X to the negative third. Where did that end up? Ooh, ended up in the denominator, right? It's negative form in the numerator, end up not positive in the denominator. Okay, here we go. Again, we're just doing some examples, processing our thinking. It takes a little time, but you'll get this. Okay, I'm going to show you again. Okay, so 2 is to the first, x is to the negative third, y is to the negative second, and z is to the fourth. So I'm going to show you a little shortcut here. Otherwise, it becomes very confusing super fast. Okay, so what we're going to do is we're cool with positive bases with positive exponents. Negative exponents, we can't have it, so we have to do their positive form, but we're going to switch its location. 2 to the first is cool, it's just 2. X to the negative third is 1 over x to the third, and what will happen is it will shift down as x to the third. Not okay. It's going to shift down. Then we look at y to the negative second. That's going to move down as y to the second into the denominator. Okay. Z to the fourth is cool where it is. It's going to stay as z to the fourth. Okay. There's a couple ways to approach it. So this is our final answer. But if we're going to do it right, it's 2 times 2 over 1 times x to the negative third, which is 1 over x to the third, times z to the negative half, which is 1 over, y to the negative 2, which is y over 2, and z to the fourth, which is 1 over z to the fourth. We can see that the 2 stays in the numerator, and it's all of these that end up being in the denominator. Oh, now it makes sense. Right. And it just takes some practice. So, take some time, pause, do classwork number 1, give this a try, and then we'll come back and talk about it. I'm just going to give you the answers. Pause. All right, so there's the answers to classwork 1. We do have to get into a little bit more with some other tricky stuff. What we have to talk about is what happens if we start with a negative exponent in the denominator, right? For example, 3 over y to the negative third. That's 3 divided by y to the negative fifth, right? Which is 3 divided by 1 over y to the fifth. And we always multiply by the reciprocal, so, keep, change, flip. So we get 3 y to the fifth over 1. Okay, what do you notice about a negative base, a base with a negative exponent in the denominator? Well, it ends up being positive exponent in the numerator. And that's actually the rule. So if you have 1 over anything divided by a base to the negative exponent, we can write that as 1 times a to the b, or just a to the b power over 1. So we're going to give it a try. It ends up being just a bunch of switching. So here we go. 2s to the 6th divided by r to the negative third. 2 is okay, it's 2 over 1. S to the 6th is s to the 6 over 1. And we're going to divide by 1 over r to the negative third. So, well, and that doesn't, what we're going to find is that this r to the negative third in the numerator is the same as r to the third. R to the negative third in the denominator is r to the third in the numerator. So 2 stays, s to the 6 stays, and r to the third is going to shift up. So we get 2, s to the 6, r to the third. Give Lamo. Okay, and it becomes even easier. We're going to need a fraction. A, which is 1 in the front. A to the negative 4, it's not cool. We need to shift it to the denominator. It's a to the 4th. Go to the denominator. The 5 has a positive exponent, so we're good. B to the negative 9th, not cool in the denominator. We're going to shift it up to the numerator as b to the 9th. Positive, so we get b to the 9th over 5a to the 4th. It becomes a shifting of up and down. Okay, let's do another one here, number 3. Let's just start with a fraction in general. 5, good. M to the 5th, also good. K to the negative 6th, Simplify that to k to the 6 in the denominator. 2, good. J to the 2nd, also good in the denominator, but n to the negative 7 in the denominator needs to shift up as n to the positive 7th in the numerator. So we're going to simplify. Here you go. Boom. All right, so classwork, the second part, which I think is the finish for homework, I'm not sure, but go ahead, jump on the second part of classwork. I'm going to do the answers, so they're up there, and if you were confused, I can point you to it. All right, so there are the answers to the second part of classwork. If you have questions, you can obviously ask me in class, or you wanted to see more work on any of those, we can do it. But it's kind of just remembering the rules, shift up or shift down depending on the negative exponent. All right, everyone, I'll see you next lesson.